In this video, we're going to cover the upper portion of the Purdue model, the DMZ and levels 4 and 5. The DMZ is arguably the most important architectural element in the entire model, the component that makes it possible for OT and IT networks to share data without opening a direct path between them. Understanding it correctly determines whether your network architecture provides real protection or just the appearance of it. The DMZ, demilitarized zone, sits between the OT environment, levels 0 through 3, and the enterprise network, levels 4 and 5. The term comes from the military concept of a buffer zone between two opposing sides, neutral ground that neither side controls directly, where activity can be monitored. In a network architecture, the DMZ is a controlled buffer zone with firewalls on both sides, one between the OT network and the DMZ, and another between the DMZ and the IT network. No system in the OT environment connects directly to the IT, and no system in IT connects directly to OT. Data that needs to cross the boundary does so through the DMZ. Applications that serve both OT and IT are hosted in the DMZ. The historian server, which needs to receive data from OT and make that data available to IT reporting tools, belongs in the DMZ, not in either zone. A data sharing server that provides production metrics to ERP systems lives in the DMZ. Remote vendor access terminates in the DMZ, not on OT devices directly. The core principle is this: there are no direct connections between OT and IT ever. Every data exchange passes through a controlled intermediary, and that intermediary is the DMZ. The DMZ prevents a compromised IT system from directly reaching OT devices, and it prevents a compromised OT device from directly communicating outward to IT or to the internet. Consider what happens without a DMZ. A historian server with one network interface on the IT network and another on the OT network is a direct bridge. An attacker who compromises the historian through the IT side immediately has a network interface on the OT side of the boundary. There's no firewall, there's no monitoring, there's no access control between that historian interface and the PLCs on the OT segment. That's a complete bypass of every perimeter control that we've talked about. With a properly designed DMZ, the historian lives in the DMZ with controlled connections in both directions. From the OT side, specific OT systems push data to the historian on specific ports. From the IT side, specific IT systems pull data from the DMZ historian on specific ports. Both directions are enforced by firewalls. An attacker who compromises the historian in the DMZ hits a firewall when they try to reach OT devices directly. They're in the DMZ buffer zone, not in the OT network itself. Remote vendor connections work the same way. The vendor's VPN session terminates in the DMZ. From the DMZ jump server, the vendor can access only the specific OT devices their work requires. There's no direct path from the internet to an OT device, whichever exists. A jump server is a machine that you position inside the DMZ for that purpose, for vendors or other to be able to access, come through one side of the DMZ, and then get into the OT side. Level 4 of the Purdue model is business logistics, the enterprise IT network. ERP systems, email, HR applications, financial systems, and corporate business systems all would be in this level. This is the environment that most IT security teams are primarily responsible for. Level 4 has the largest attack surface in the organization. More users, more software, more external facing services, more email, more web browsing, more potential entry points. In the 2015 Ukraine power grid attack, the attackers entered through spear phishing emails at level 4 and worked their way down through the enterprise network before reaching OT systems. The attack succeeded again because the path from level 4 to OT was not adequately blocked. Level 5 is the connection to external networks, the internet and any external partner or customer connections. This is where the organization interfaces with the world and where external attackers have their starting point. A properly designed DMZ means that a breach at level 4 or 5 is stopped at the DMZ boundary. The attacker has the enterprise IT environment, which is serious, but they face another firewall-enforced boundary before they can reach OT systems. If the DMZ is well configured, that boundary holds. The DMZ concept is widely understood, but the implementation frequently has gaps that undermine its purpose. The most common failure is the dual-homed server, or a server with interfaces in both IT and OT, which bypasses the DMZ entirely. This shows up most often with historian servers configured this way for simplicity. The correct fix is to place those servers in the DMZ and use firewall rules to control access in both directions. Another common failure is overly permissive rules on the DMZ firewalls. A DMZ that allows any IP address in the enterprise network to connect to any service in the DMZ is not really providing any meaningful protection. DMZ firewall rules should be as specific as any other firewall rules: specific source, specific destination, specific port, and a documented business reason. A third failure is allowing devices in the DMZ to initiate connections into the OT network. Data should flow from OT into the DMZ, not the other way. OT systems push data to the DMZ historian. Enterprise systems pull from the DMZ historian. The DMZ should never initiate connections into OT, only receive them. In the next video, we'll cover data diodes, the hardware solution for environments where even a misconfigured firewall represents too much risk.